How you doing, guys? So we're going to see a weekly contest for 3 for problem. The third problem. The says maximum frequency after stable operation. Let me just give you the overview of the problem real quick. Then we'll discuss about the solution. And we're given a list of numbers, and we're also given an integer k, and we can select the subarray from the nums, and we can add any value to the elements of the subarray, and we might select an empty subarray. So in our case, we might select uh, a subarray starting from 2 and ending up to 6. Doesn't matter, we can add any value to it, but the target of the problem is to maximize the frequency of k, in our case, which is 1. So we can select a subarray containing only 6, and we can add -5 to it, and that will give us 1 having frequency of 2 at the end. And yeah, you might think to add more, but you can't, because that's the restriction of the problem. And yeah, the first thing that you might think is to count the occurrence of uh, each unique element, and pick the one having maximum frequency which is different from k, and add them with the frequency of k, and that will give you the answer. That's what I thought first, but that's not going to work actually. So let's see what I meant by that. So we're going to select the subarray containing 6, and we add -5 to that subarray, and 6 is going to be minus this 6 is going to be 1, obviously. And when we add it with the one that we had before, that was going to give us 1 having a frequency of 2. Sorry. And yeah, that's what I was trying to say, but this is not going to work. Let's see this example. So as you can see, 2 have 5 frequency, and 1 have 1 frequency. Actually, not 1, 3 have 1 frequency. So based on the first idea, so we select the whole subarray, and we have 2 or having frequency of 5, and if we add 1 to all of the elements, that would give us extra 5 threes, and we add that with the 3 that we had before, and that would give us 6. But if you see that, the answer is not 6, because it's supposed to be 5. And the reason is that when we pick the whole subarray, we have to add 1 to all the elements. And when we do that, we also added 1 to the 3 in the middle. And that will give us 1, 4, which is not 3. So in that case, it's going to be 5, because we only have 5 threes now. Another thing that we also keep in mind is that a number that is having maximum frequency is not going to lead us to the answer. So what I mean by that, in this case, if we are required to maximize the occurrence of 3, we might think, so since to have frequency of 2, we should select 2, and we're going to change that to 3, but that would give us a bad answer, because we're going to lose the 3 threes in the middle. So the 3 threes, yeah, the meaning that the 3 having 3 frequencies in the middle. Yeah, but what we can do is that we can select the 0 in the middle, and we can add 3 to that subarray, and that would give us 4. So the point that I was trying to make over here is that the number that is having maximum frequency, and which is different from k, is not going to lead us to the answer. That are the 2 things that you need to keep in mind, and you might select one of the twos the one in the front or the one in the back. So it's also going to give you the same answer in this case. So we have to think of another way to solve this problem, right? Because seems like this is not going to work. So the key point to observe here is that the constraint, so the numbers are only 50. So we have only 50 unique numbers. So what do we do from here? So we assume each number to be a potential answer, and then we attempt to find the maximum contiguous sequence containing the maximum frequency of that number, but minimum of k. Uh, so, for example, if we see at this example, we select the whole subarray in our case 3, it has more 2's and less 3's, meaning that we need a subarray containing minimum of k, maximum of the current number that we choose. So I assumed that we choose 2 in this case. So let's just visualize what I said. So we're going to assume that every element in the nums is going to lead us to the answer. So first we're going to pick 2 and hoping that it will give us the answer. And we're going to have 2 variables, and that's going to be the current count of 2's. Actually, not 2's in the overall problem. The current number that we choose to lead us to the solution, and the overall maximum. And now we pick 2, so we're going to count the subarray containing 2, and we're going to use kind of Kirani's algorithm here, and we're going to count the number of 2's we have in the subarray that we are choosing. And we pick the first subarray and we expand it, and the overall maximum is going to update with 2's count. So whenever we have a maximum 2's count, it's going to update to that count. And when we have 3, since 3 is equal to k, so we know that if we include 3 in our subarray, we're going to lose it, because we know that we're going to add any number to it, and we know that we're going to lose it. So we're going to reduce it from 2's count, and as you may know, like when we move forward, the 2's count is going to increase, but we might have a bunch of 3's in front, right? So what should we do in that case? So let me change the program to that, and let's try to visualize what's going to happen. So we're going to move forward, and 2's count is equal to 0. What does that mean? So from the subarray that we choose, we're benefiting nothing. That's what it means. So we picked the subarray starting at 2 and ending at 3. So the 2, we can make it 3, but when we try to make that 3, we're going to lose the 3's that we selected in the subarray. But if you see, the overall maximum stays 2. So the first subarray is going to be the solution, but the 2's count is now 0. And we still move forward. Now we have -1. Then what does this mean? So if we still keep choosing this to be the subarray, we're losing more 3's. So in that case, we're going to start from 0, making 2's count from 0. That's a part of Kidani's rules algorithm. So that's what it would look like. So let me just get back to the original example. And when we move forward, we have 2, and 2's count actually is going to be 2, and again 2's count is going to be incremented, 2's count again is going to be incremented. The overall maximum is going to change because we are actually phasing the maximum number that we had in before. Now let's assume the 3 is going to lead us to the answer. The overall maximum is still going to stay 4. So we move forward, and 2 is not equal to 3. Again, 2 is not equal to 3. But our 3's count is going to stay 0, because at the same time we have to count for 3, and also we have to reduce if the current number is equal to k. That's why it is 0. So if the number that we are assuming is going to lead us to the answer is equal to k, actually we're going to have a 0 count at the end. That's obvious. Then we keep moving. So we have an overall maximum to be a 4. So we picked a number, and that number gave us a subarray containing that number is equal to 4. So without considering k. So meaning that the answer is going to be the overall maximum summed up with the count of k in the array. So that is the idea of the solution. So let's code this solution up, and we're going to have we're going to keep every element in nums. We're going to count them. Actually, this is not for the purpose to count, but to have a unique element. And we have maximum. Let's call it overall max. It's going to be 0. Then for I in count, so that will give us the unique elements. So we are assuming that the current num is going to lead us to the solution. So we're going to iterate over the nums, and if the current number is actually equal to number, we're going to also we need to have a current count. So that is going to be a nums count. We can say num count. So that was the twos count that we were having, the threes count and the twos count. And if the current number is actually equal to num that we picked, we're going to increment the num count by 1. And if the number is equal to k, we are going to decrement the num count by 1. And obviously, if the num count becomes 0, less than 0, we have to choose 0 as starting point. And after that, our overall maximum is going to be maximum of the current num count and the overall maximum we had before. So that was give the overall maximum, and we're going to return the overall maximum summed up with the count of k. So this should work. Let's try it out. So as you can see, it's working. Yeah, that was the solution. If you liked it, you can like the video for me. Thank you.